Okay, so we're going to be using substitution to find the point of intersection between two lines. Now these are two lines, and we're used to seeing lines written as, y equals mx plus b, right?
Yeah.
But in this case, they've just set these lines equal to a different variable. Okay, so they do have a y, and the x is technically only to the power of 1, so we know they're linear. Okay, so they're straight lines. And the way we can find a point of intersection is, setting up a graph and then drawing two lines, and here's the point where they intersect each other, right? But if we don't have a graph, or maybe it's going to be a big process, something we can do is called substitution. And first of all, in order to substitute, we have to figure out how many variables we have. And we have two different variables, okay? And because we have two different variables, we'll need two equations to solve. So I have equation 1 and equation 2. So however many variables you have, you need that many equations to solve it. So when we used to have maybe one variable, something like x equals 3 plus 8 x, let's say, we can solve for x because we have one equation. But as soon as there's two variables involved, we're going to need two equations to solve for it, okay? So we have two equations here. And sometimes they tell you to, substitute one into the other, but we really have a choice. We can choose to set an equation equal to a variable. Now, if we look at our second equation, it's not really set equal to just a variable by itself, right? It's set equal to -10 on one side. We'd have to manipulate the equation and set it equal to either y or x before we can get into our substitution. But in equation 1, they've done a lot of the work for us. They've already set it equal to x, okay? So that's great. Because they've set it equal to x, what it's saying is x is equal to this. So in our second equation, we can substitute this in place of the x because those two things are equal, okay? So we're going to go about doing that. We have our equation 1, okay? Equation 1 and equation 2. So we have x is equal to 5y plus 8. And we know x is equal to that, so what I'm going to do is I'm going to put little brackets around it. We're going to take equation 2, and we're going to replace the x. So we have 3 times, here we have 5y plus 8. Okay, and that's exactly what we had over here. So we placed x with that value, plus 2y equals -10. Now there's only one variable left. What variable is left? There's only a y left. So now we can solve for this, right? There's only one equation, kind of, with a variable. So the first step is we have to remember to distribute. We got to follow our bedmass here. And because of bedmass, we need to deal with this multiplication. Do you remember doing distributive property a little?
A little bit, yeah.
A little? Okay. So because it's multiplication, we need to distribute this value. So that means we have to take 3 and multiply it times 5y, and 3 and multiply it times 8. So when we do that, what's 3 times 5? Do you remember? Yeah, so we have 15y. And what's 3 times 8?
Help
you out.
Oh, yeah.
Okay.
24.
Okay, so we've just distributed, plus we still have the 2y is equal to -10. We want to collect our like terms, okay? So we have 15y and 2y. What is 15y plus 2y?
17y.
That's right, so we have 17y plus 24 equals -10. The goal is to isolate for y right now, right? So I'm going to move 24 to the other side of the equation, and when we do that, what does it become?
A negative.
That's right. So we have 17y is equal to -10 minus 24. Okay, so 17y is going to be equal to, this will be -34. Okay, and we still have to isolate for y. So since it says 17 times y, what do we have to do here to move that 17 to the other side?
You divide.
That's right, because it's multiplication, we have to divide. So -34 divided by 17 is actually the value of -2. So remember we talked about how this is solving for where the two lines cross each other? What we've just discovered is the actual coordinate for the x. Oh, sorry, not the x. What am I saying? It's not x, it's y. Made a little error there. Okay. We found the coordinate for the y value. So we already know the y value is -2. Now we can go right back to the beginning. We have our two equations. I can plug in -2 because we know y is equal to -2 into either of these equations. And we can plug -2 in for either of the y's, and it will solve x, and it'll give us the same value. So since we haven't used the first equation yet, let's use that one when we go through this, okay? So we're going to take this first equation again, and if you remember, it's lagging a little here. It said x was equal to, so equation 1, 5y plus 8, okay? And remember, our answer was y was equal to -2, so we're going to replace y with -2. So x is equal to 5 times -2 plus 8. We do BEDMAS here. 5 times -2 will give us -10 plus 8. When we take a calculator and put those together, we're going to get -2 again. So it ends up being the exact same. So our coordinate, where the two lines cross, would be at -2 and -2. Okay. So that's the process. There's quite a few things we have to do here. Isolate and then substitute it.